Okay, so next point we can see the common properties of d block elements. So first one we can see the physical properties. So first physical properties is all the d block elements are lustrous and shining in nature. Lustrous and shining in nature. So second, they are hard in nature and their density are very higher. Density are very higher. They have high melting point and boiling point. They have high melting point and boiling point. They are good conductor of electrical and thermal conduction. They are good electrical and thermal conduction. They have high tensile strength and malleability. They have high tensile strength and malleability. And they can form alloys. And most of the d block elements are paramagnetic in nature. Their nature are paramagnetic in nature. And most of the transition elements are used as a catalyst in various chemical reaction. So these are the some physical properties of transition elements. Next point we can see, that is known as a chemical properties of transition elements. So first one, all the d block elements are electropositive in nature. Are electropositive in nature. All the d block elements are electropositive in nature. Electropositive metals, they exhibit variable oxidation state. They exhibit variable oxidation state. They are good reducing agents. They are good reducing agents and they form insoluble oxide and hydroxide. They form insoluble oxide and hydroxide. Okay, and some transition elements like iron, cobalt, copper, molybdenum and zinc are biologically active or important metals. Biologically important metals, and in most of the chemical reaction they are used as a catalyst. Okay, next point we can see the inner transition elements, that is known as a block element, which include two series. One is known as a lanthanoid and second one is known as a actinoids. So a block elements means the last electron enter in. The last electron enter in f orbital are called f block elements, These elements are placed separately at the bottom of the periodic table, and they are present in 6th period and the 7th period. So normally lanthanoid are placed in 6th period and actinoid are placed in 7th period, and both are present in the 3rd group. So that is the position of lanthanoid and actinoid in the periodic table. So lanthanoid and actinoid has 14 elements, and the electrons are filled in 4f and 5f orbital. So next point we can see, that is the properties of a block element. Okay, properties of a block element. So first, their properties are similar to D block elements. The electrons are added in F subshell, and they are placed between n-1 D and ns block elements. Okay, lanthanoid elements are starting from atomic number 57 to atomic number 71, and these are known as rare earth elements. Okay, the metals are soft. Lanthanoid metals are soft in nature. They have moderate density. They have high melting point and boiling points. Their melting point and boiling points are high. Higher melting point and higher boiling points are present. Then they react with the water to give metal hydroxide and hydrogen gas. So M is the any lanthanoid element, and if it is reacted with the water, it gives metal hydroxide and with liberation of hydrogen gas. Most of the lanthanoid has common oxidation state is +3. The common oxidation state of lanthanoid is +3. Along that they can show +2 oxidation state, which is also very important, and they also form a stable oxides of the type M2O3. Stable oxides of the type M2O3. So along that lanthanoid can show two oxidation state, one that is +2, +3 is a common oxidation state, and another one is higher oxidation state, that is +4. The species which show +2 oxidation state are behave as a reducing agent, and the species which has higher oxidation state are behave as a oxidizing agent. oxidizing agent. Okay, next point we can see the radius of the lanthanoid. So ionic radius decreases from ionic radius decreases from 117 picometer of lanthanum to 100 picometer of lutetium. This is because the 5f orbital do not shield, because 5f orbital do not shield the outer 5s, the outer 5s and 5p electrons. So which increase in effective nuclear charge and decrease in ionic size. Such large ions have higher coordination number that varies from 6 to 9, 10, 12. For example, in case of LaH2O 9 times bracket raised to plus 3, they have hydrated, nanohydrated compound. So all the lanthanum hydroxides or all the lanthanum hydroxides are generally represented as LnOH thrice, and these are ionic and basic in nature. These are ionic and the basic in nature. So their size decreases from their size decreases from lanthanum plus 3 to lutetium plus 3, and the basicity of hydroxides decreases. So we can say that lanthanum hydroxide is a strongest base, and lutetium hydroxide is the weakest base. The next point we can see lanthanum react with a nitrogen and it forms lanthanum nitride. Lanthanum nitride. Next reaction, when lanthanum is reacted with a halogen, lanthanum Ln is any lanthanoid element. When it is reacted with a halogen, we will get lanthanum halide. Lanthanum halide. Okay, most of the lanthanoids are colored in nature. Mostly green, pink and yellow. Mostly green, pink and yellow, and this is due to electronic configuration and which containing large number of unpaired electrons. So next point we can see, that is known as the properties of lanthanoids. The next point we can see the properties of lanthanoids. So first, lanthanoids are soft metals. Lanthanides are soft metals with silvery white color, and they have moderate density. Color and brightness reduces on exposure to air. Lanthanoids are good conductors of heat and electricity. Lanthanoids are good conductor of heat and electricity, except promethium. All are non-radioactive in nature. All are non-radioactive in nature, and the important point is the atomic and ionic radius decreases from lanthanum to lutetium, and this is known as lanthanoid contraction. Okay, binding to water is a common. H2O is found in food products when isolated from aqueous solution. Coordination number are usually greater than 6. Means 8, 9, 12. Lanthanoids are strongly paramagnetic in nature. Lanthanoids are strongly paramagnetic in nature, and gadolinium becomes ferromagnetic below 16 degrees Celsius, that is known as a Curie point. And most of the lanthanides are ferromagnetic in nature. Magnetic and optical properties. Magnetic and optical properties are largely independent of environment.